In this lesson, we're going to talk about slope, really a very main idea of 8th grade, 9th grade algebra and future math classes such as calculus. Slope is, and this is the key word, a ratio. It's the ratio of the change in the y coordinates on a line to the change in the x coordinates on the line. So this, to me, is the main idea. And if you can keep that in your head, and you do have to remember it's y change over x change, that's all you really need to know. There's this crazy formula it looks crazy, but it's quite easy of how to calculate the slope. And there are these phrases, rise over run, to help you keep straight, but I think they can be misleading. I would focus on it's the ratio of how the y variable changes. So y is how high the line is. So you have a y value here and a y value here. How much did it change? Which is just a subtraction. And you have the x value of a point and the next x value of the next point. How did they change? And that's subtraction. So the formula, let's talk about it for a second. It has subscripts. So let's talk about how we read this formula. We say this y sub 2 minus y sub 1. Let me make it a little bit bigger for you all. Okay. So we say this y sub 2 minus y sub 1 over or divided by x sub 2 minus x sub 1. What are those subscripts? They're not exponents. They're not little variables, little numbers above the variable. They're just saying that I have a point over here, and I'm going to call that my first point. And so I can understand and distinguish it from the second point. I put a little 1 to the right and below. So the first point's over here, the second point's over there. And so the y value of the second point is called y sub 2. That's all it is. Now, the basic idea is we saw and graphed linear equations yesterday, and some of them slanted up to the right, and some of them slanted down. And the angle that they make are different. So the slope is a way to measure and show direction. Okay, the slope tells us which direction. So if it's positive, it slopes up to the right. And if we have a negative slope, it's when it's down to the right. And how big the slope is also can measure that angle that it's making. So let's take a look at this with some specific examples. It'll clear things up. So in this example, someone gave me a graph. Now there's, as we saw, infinite number of points on the graph. They labeled this point, -3, -1, and this point 3, 4. They could have labeled other points, okay, but those are the two they labeled. So I'm going to use them to use my slope and put it into the slope formula. So again, let's scroll up for a second so we can see both. Well, maybe I won't see both. Okay, so there's the formula. So I need to label one point as the first point and one point as the second point. It doesn't matter which one you call which. So don't hesitate. Just say, oh, I like this point. It's the first one I see. It's x1, y1. And the next one is x2, y2. And the formula says take the two y values and subtract them. And I have to be careful because there's some negatives in here. y2 minus y1, x2 minus x1. Keep change opposite. 4 plus 1 equals 5. 3 plus 3 gives me 6. So we say this line has a positive slope of 5/6. And notice here, they labeled it and put the numbers here. I just want to be absolutely clear. This is not 5 because 1, 2, 3, 4, 5 boxes. It is 5 because the difference between 4 and -1 is 5. This is 6 because the difference between 3 and -3 is 6. Now, what if someone else had looked at these 2 points and labeled it the other way? So they looked at it and said, I see 3, 4 first. That's my first point. And -3, -1 is my second point. Second x, second y. Would they get a different slope? I hope not, because slope is a measurement, an intrinsic measurement of the line. So they would have done -1, y2 minus 4, -3 minus 3. And instead of getting 5/6, they would get -5/6. But a negative divided by a negative is a positive, so when they simplify that fraction, they would get the exact same slope. So which point you label x1 and y1 and which point you label x2 and y2 does not matter. And that's because this line slants up to the right. It has a positive slope. It doesn't matter which point I call which. The slope is the slope. Now, sometimes you'll be given a problem and you'll just have two data points, two values that they say lie on a line. So in this example, it says, find the slope of the line through the given points. So you can imagine, and you can even sketch, that you have these 2 points, -1, 1, 1, -2. And if you want, and I like to do this a lot, sketch it in your head or sketch it on the piece of paper so you have a visual of it. But you don't need the actual graph to use this formula. So I am going to label the first point x1, y1, and the second point x2, y2, and apply the formula. How did y change? Y went from 1 to -2, so I'm going to find that difference. And the x value changed. It was -1, and now it's 1. I find the difference. -3/2. And this has a slope of -3/2. Now I put the negative sign in the numerator. Most often, after you do the calculation, we'll put the negative sign out front just to say that this is a negative number, -3/2.